Hello class. Today we are going to talk about the equations of parallel and perpendicular lines. Now before we start into that, I want to do a quick review on some things you may have done in Algebra 1, maybe even in pre-algebra, 8th grade math, maybe something in there. Write the equation of a line with a given slope that goes to a given point. So in this case, a slope of 3 that goes to the point 4, 5. Now there are two ways that we can do this. One, we can use slope-intercept form. The other is point-slope form. Okay, and I've done it both ways here, so you can see this. Slope-intercept form, y equals mx plus b. And basically what we do is substitute in for x, y, and m. All right, so x is 4, y is 5, m is 3. M is your slope, remember. So you just plug in for that, and you solve for b. What is the y-intercept? All right. So 3 times 4 is 12. Subtract your 12 from both sides. B is negative 7. Then you plug in slope and y-intercept, your b, and y equals 3x minus 7. The other format is the point-slope form. This is y minus y1 equals m times x minus x1, where y1 and x1 are from the point. So here again, we need a point, we need a slope. This time we don't have to have the slope, the y-intercept, doesn't matter as long as we have some point and a slope. Again, we start off the same way. Substitute in for, instead of x and y, we're substituting in for x1 and y1. Still substituting in the slope for m. So we now have y minus 5 equals 3 times x minus 4. And here we just solve for y, get y by itself. So we distribute the 3 in, we end up with y minus 5 equals 3x minus 12. Add 5 to both sides, and we have y equals 3x minus 7. So again, we have the same thing. And usually we are going to want it in slope-intercept form, but we might be easier to start in point-slope form and get it into slope-intercept form. All right? So two ways to do things. We're going to use both ways. It doesn't matter which one you use. They both get the exact same answer. So mostly it's just up to you. Which one do you like? Because they both work. They're both good. All right, so we're going to do a couple examples here. These are slightly more complicated in that they are not going to give us the slope. What they're going to do instead is say, write the equation of a line that passes through the given point, point P, and in this case, we want ones that are parallel to the given line. All right, so let's remind ourselves from the last video, we saw that lines that were parallel have the same slope. So slope of line 1 is equal to the slope of line 2. They have the same slope. So on problem 1 here, what is the slope that we want to use? Well, the slope of the line they give us, the slope is right here, negative 6, right? Because it's mx plus b. So that's the slope of the line that you give us. We want a line parallel to that, so the slope is going to be the same. So the slope for our line is also going to be negative 6. Now, we can use either one. We can use point-slope form. We can use slope-intercept form, whichever one you like. I'm going to use slope-intercept form on this one. Y equals mx plus b. And now I'm just going to plug stuff in. Okay, I know y comes from right here. That is negative 4. I know m is my slope. That is negative 6. X, I'm going to plug in the negative 1 from this x coordinate. And I don't know what b is. Don't know. So plus b, I have to solve for b. Well, that's no big deal. That's not a problem. Let's see. We're going to multiply here first. So negative 4 equals positive 6 plus whatever b is. Subtract the 6 from both sides. And I end up with negative 10 equals b. So my equation, back to this y equals mx plus b, y equals m, negative 6, x plus, well, in this case, minus 10. That could be plus and negative 10, so minus 10. Okay? Now, it also says to graph the equations of the lines to check that they are parallel. Right? Well, they're in slope-intercept form, so they're very easy to graph. I changed the scale to go up by 2s because this one here starts at 8, and I figure this one is at negative 10. So let's start this one. We'll do this one in blue. So let's see, we start with our y-intercept, begin with b, right? B is for begin. So y-intercept of positive 8. So that would be right there. I'm going to put a dot. And then my slope is negative 6. Okay, so that means I'm going to go down 6 over 1. 2, 4, 6 over 1, which puts me kind of there in the middle, so I don't really like that, so I'm going to go down 6 more. 2, 4, 6 over 1. That gets me at a lattice point, so that's good. Always use a straight edge when you're doing this, especially since you're trying to find are these parallel or not. And if you don't have a straight edge, they might look parallel just because you drew them wrong, right? But if you got a straight edge, it makes it a lot better. It looks a lot neater. So there's the one that they were given. Now let's draw the one that we calculated and see if they come out looking parallel. So let's see here. Negative 10 is our y-intercept, so that would be right here. And then slope of negative 6. Well, I can't go down, so I'll go backwards. So instead of going down 6 and right 1, we will go up 6 and back 1. And again, we're not on our lattice point, so let's do it again. Up 6 and back 1, and that puts it right there. And let's draw this line. Just my straight edge. And there it is. We see, yep, those look parallel, don't they? That looks good. So what I would like for you to do, pause the video and work out number 2. Let's see how you did. First, what is the slope? Slope is going to be the same. So the slope is going to equal 2/9. And this time I'm going to work this out using point slope form. So y minus y1 equals m times x minus x1. And now I just plug stuff in. Plugged it in. Now we just solve for x. That's all we got to do. Solving for x. Okay, so now we have our answer. Y equals 2/9 x minus 4 and 5/9. All right. Let's graph this because it wants us to graph it. See how they look. Again, start with your y-intercept. So we'll do this one here in blue. And this is going to be a little bit uglier because my scale doesn't quite allow for it to go on the axis. And we got fractions there. So let's take a look. And the other one is at negative 4 and 5/9, which is a little bit annoying. That's not quite here, kind of sort of there. All right, up 2. And so that'll make it at 2 and 5/9, and then we're going to go right 9. And it looks pretty good. I'm going to check this in the calculator because with the fractions and stuff and my scale being the way it is, a little hard to see. Want to make sure we get it right. So there it is, graphed on the calculator, so it's a little bit better. And we see, yes, indeed, it is parallel. So that's good. Let's put the calculator away. All right, so that is parallel lines. Now let's do some down here, slightly different. Here, instead of looking at parallel lines, now we want to find lines that are perpendicular to the given line. It's still going to work the same way. It's just instead of having our slopes the same, our slopes are perpendicular, which you'll remember from the previous video, the way this works. The slope of the first line times the slope of the second line is going to equal -1. Or a little bit easier way to think of it, the slopes will be negative reciprocals or opposite reciprocals. So on number 3, the slope of the line they give us is 4, right, because mx. So that means the slope that we want is going to be the opposite reciprocal. Since 4 is positive, we're going to have a negative, and this would be 4 over 1 as a fraction, so reciprocal of that would be 1 over 4. All right, so I am going to solve this one with, I'll do point slope form, because why not? And we plug stuff in. All right, so we have stuff plugged in, x, y, and the m that we want. And now we just solve this. So no big deal. That's easy enough to do. Y plus 3 equals -1/4 x. Distribute that in. So that would be plus 1/4. Subtract 3 from both sides. And y equals -1/4 x minus 2 and 3/4. We're subtracting 3. And this is the equation. Now again, it does want us to graph these. So we'll take the first one. We'll do this one in blue. So my y-intercept is -7, which we put it right here. And the slope is 4. So that means up 4. So 1, 2, 3, 4 over 1. And it's kind of in the middle. I don't want to put it in the middle. So let's go 1, 2, 3, 4 over 1. Still not great, but at least it's on a grid line, right? Always use a straight edge. Okay, so that's the original line. And then the line we wanted has, let's see, -2 and 3/4. So -2 and 3/4, almost 3. So put it right there. And the slope is down 1, right 4. So down 1, right 1, 2, 3, 4. Down 1, right. And just to check, this does look perpendicular, right? Looks good. And does it go through the point 1, -3? This is the point 1. Again, remember my scale is going up by 2s. -3, so 2, 3. Right about there. A little hard to graph it exactly because I have a fraction for my y-intercept. So I'm going to pull this one up on the calculator as well. And I did this as decimals just because it's faster to type it in. I'm going to change my zoom to square it up because otherwise it's not going to look quite right. I want to make sure my aspect ratio is square. And there we see, yes, it is perpendicular. Looks a little bit better there. And if I go to the table, it does go through the point 1, -3. Right there. All right, so that's that. That's good. I would like for you to pause the video and work out number 4. Right. First, your slope. Again, slope is not the same slope because we want perpendicular lines. So the original slope is negative, so I want a positive. We take the reciprocal, so that's 3/4. And just because, why not? I'm going to solve this using slope-intercept form. Plug in for x, y, and m. Solve for b. And then write our equation. All right. So hopefully that's what you got. Let's graph it. In this case, I did not change my scale because 5 is going to fit, 3/2 is going to fit, slope's pretty small, so it should work. And we're going down 4. Right 3. Use a straight edge. And let's see, here we have 3/2, so that's right there. Up 3, right 4. There it is. They are perpendicular, and you'll see it does go through the point -2, 0. All right. So it's good. It works. Not too bad. This, unfortunately, is the easy stuff. Okay. Here is where it gets difficult. What we want to do is find the distance from point P to the given line. Okay. And we are going to take this in steps. Okay. First, you remember the distance from a point to a line is always a perpendicular segment. Okay, so we need to find a segment perpendicular to the line. So that's step 1. We need to find a perpendicular line. So if it's perpendicular, remember, what is the slope? That's right. The slope is going to be the opposite reciprocal of the slope they gave us. So the slope that I want is going to be, well, this is positive, so I want a negative, and the reciprocal of 2 will be 1/2. So that's the slope I want. And we can do this whichever way we like. I'm just going to do this in point slope form. All right, so let's plug in. Okay, and then we get y by itself. So now I have the equation of a line perpendicular to the given line. All right, and you know what? This might help if we graph it. Let's go ahead and graph this. So we'll graph this y equals 2x minus 6. So we start at -6 right here. And we have a slope of 2x. So up 2, right 1. And point P is at 4, 8. There's point P. So this line here should be perpendicular to the given line, to the blue line, going through that point. So let's see, starting at 10, And our slope is going to go down 1, right 2. There it is. It does go through the point, so that's good. So there it is. We have our perpendicular line. Oh, we don't really want the whole line. All we want is from point P, right here, to the intersection, which is right here. You'll notice that is not on a lattice point, so it's not going to be an integer. It doesn't look to be half. It's going to be some hideous, ugly decimal. Yeah. Whatever. So we're going to call this, I don't know, we'll just call this point A because we got to call it something. And that's what we need to do. We need to find out where point A is because what we want is the distance from P to A. That's what we want. So to do that, first we have to find point A. So we have to find the intersection. And to do that, we're looking for where these two equal, right? So that's what we're going to do. We're going to set this one equal to that one. And then we just solve it. So let's get our x's to one side. Move our constants over. Divide by 2.5. And x equals 6 and 2/5. Or if you prefer, we could also call this 6.4. A little bit easier to deal with, right? So now, what do? That's our x, but we want an ordered pair there, right? So that's no good. What we need to do is take this x and plug it back into either one of these lines, doesn't matter which one, and get y. So y is going to equal, let's plug into the blue line, that'll be easiest. 2 times 6.4 minus 6, and so y equals 6.8. Right? So the coordinates of point A are 6.4, 6.8. But again, we didn't just want the point, we need to know the distance. So now we need to find the distance. All right, and for that, of course, we are going to use the distance formula. All right, so the length of PA equals the square root of x1, well, that would be P, for minus x2 squared plus y1, again from point P, 8, minus y2, which is the one we just found, squared. And we will take this lovely mess there and we will type that all into our calculator. And so the distance of PA is approximately 2.68 units. And there it is. It's a lot of work. I understand. It takes a bit. Got a couple of steps we got to go through. It is a process. It's not super hard, but yes, it is a process. All right, so now I would like for you to pause the video and see if you can't find the distance from point P to this line here. Step 1, remember, is to find a perpendicular line. Again, remember, we want a slope that is opposite reciprocal because it's perpendicular. So this is positive, I want a negative. Reciprocal of 1/4 would be 4/1 or just 4. And you can use whichever format you like. I'm going to do point slope, slope-intercept, why not? And now we just plug things in. Solve for B, rewrite our equation. And you know what, let's go ahead and graph these two lines just to make sure that we got it right. So I'm going to graph these on the same graph, I'm just going to do them in a different color. And this one had a y-intercept of -7 and a slope of -4. I don't have room, so I'm going to go up 4, back 1. And we see we do have a perpendicular line. It does go through the point -2, 1, so we're good there. And so we need, again, the distance between point P and the line, which is going to be some intersection. Again, it's not quite on the lattice, so we can't tell, some point right there. All right, so we need to go from point P to, we will call this one, why not point B? Gotta call it something. So now we need to find B. So we set the two equations equal to each other. Solve for x. And x equals approximately negative 0.94. And now that we have x, we take that and we plug it back in to find y. And you can plug into either one. I'm going to plug into this one. That looks a little bit easier. And so y is approximately negative 3.23. So point B is approximately negative 0.94, negative 3.23. And now that we know the coordinates for B, we can find the distance. The length of segment PB is going to be, we're going to use the distance formula using point P and point B. And I'm just going to take that, stick that whole thing into my calculator and get an answer, which is approximately 4.37 units. Right under, there it is, 4.37 units. So, a lot of work, yeah. Do we get ugly answers with nice, great, terrible looking decimals? Yeah. Not the easiest stuff we've done all year. But still, it's not completely and totally terrible. It is a bit of a process. So to find the distance from a point to a line on a coordinate grid, step 1, find the equation of a line perpendicular to the given line. Take those two equations, set them equal to each other to get your intersection. Then find the distance, use the distance formula using the original point and the new intersection, and that will give you the distance from a point to a line on a coordinate grid. All right, so hopefully that helps. Again, remember, you can use either slope-intercept form or point-slope form. Slope of a line of parallel lines are the same. Slope of perpendicular lines are opposite reciprocals, or they multiply to -1, whichever way you like it. All right, and hopefully you found that useful, and I'll see you in the next video.